and transforms the atmosphere. These stromatolites are creating the single most important element for life on Earth. Without them, virtually every living thing wouldn't exist. When we take our next breath, we're doing it thanks to these colonies of ancient bacteria. Over the next 2 billion years, oxygen levels continue to rise. And as the planet's spin slows, the days get longer. Now they last at least 16 hours. We're discovering it takes a long time to make a planet. 1.5 billion years ago, 3 billion years after the planet's birth, and there's no complex life. No plants, no dinosaurs, no humans. But the Earth has something that no other planet has. A force with the power to change everything. Our planet. A beautiful blue ball, dotted with volcanic islands. 1.5 billion years ago, it's home to primitive life. Over millions of years, we can see something is rearranging the islands. Hidden beneath the ocean, the Earth's crust has broken into vast plates. Deeper still, the Earth's core is at work. It's hotter than the surface of the sun. So hot, it generates movement in the rock beneath the crust. These movements push and pull the plates around the globe and carry the oceans and the islands with them. Millions of years race by. Seeing it like this, our planet seems active, changing, alive. Over 400 million years, a vast new supercontinent takes shape, called Rodinia. In the shallow waters around Rodinia, stromatolites have been working their magic for over 2 billion years, pumping oxygen into the atmosphere. The temperature is 30 degrees Celsius, and the days are 18 hours long. But this looks more like Mars than Earth. To find life here, we need to move on, through time. Washington, 750 million years ago. Some force from deep inside the planet itself is ripping the crust to pieces. It's as though the world is tearing apart. And there's only one force powerful enough to do this. Heat. It escapes from the Earth's molten core, stretching and weakening the crust. Centimeter by centimeter, year by year, the great supercontinent is splitting in two. Geological activity has spawned a mass of volcanoes. These pump carbon dioxide into the atmosphere. There's smoke and gas everywhere. All that carbon dioxide mixes with water to make acid rain. The rocks absorb the acid rain, including its carbon dioxide. And there are a lot of rocks on the Earth right now, exposed when the continent tore apart. So many that vast quantities of carbon dioxide are absorbed out of the atmosphere and locked up in the Earth's rocks. There's not enough carbon dioxide in the atmosphere to trap the sun's heat around the... It's the start of what some scientists call snowball Earth. A period they believe to be the longest, coldest ice age ever to grip the planet. A vast wall of ice, thousands of meters high. The ice is unstoppable. The more ice there is, the more sunlight it reflects away from the planet, and the faster the ice spreads. And there's a second ice sheet, just as high. The two sheets spread away from the poles towards each other to meet. A ice sheet up to 3 kilometers thick entombs the entire planet. First, the planet was a molten ball of fire. Now, it's a frozen ball of ice. Virtually all the sun's light and warmth reflects back into space to produce a chemical rich in oxygen. Hydrogen peroxide, the same chemical that bleaches hair. As the ice melts, the hydrogen peroxide breaks down and releases massive amounts of oxygen. The Earth is waking up, and it's a very different place. Ago, the atmosphere is warmer. It feels like a summer's day. And the days are about 22 hours long. Add all this water, and it's the perfect recipe for life. Before Snowball Earth, primitive bacteria had emerged in the oceans. But surely they couldn't have survived an ice age 75 times longer than the entire span of human history. If something has survived, then our best chance of finding it is where we last saw life, in the ocean. A handful must have clung on through the big freeze. There are plants everywhere. And something else. Looks like some kind of armored slug. It's called Wiwaxia. It's one of a new generation of complex multi-celled organisms. We're entering one of the most dynamic periods in the Earth's story, the Cambrian explosion. Increased oxygen levels allow creatures to grow larger and develop bony skeletons. There are worms, sponges, and these. They're trilobites, distant relatives of insects, lobsters, even scorpions. Life in the oceans is blossoming. From microscopic bacteria to a monster like this. This is Anomalocaris. It's about 60 centimeters long. Look at its large eyes, its razor-sharp teeth and grasping limbs. These are Pikaia. They're just 5 or so centimeters long, but they've got what may be the first ever spine. Over millions of years, this simple structure will evolve into the spine that keeps us standing erect. And creatures are beginning to take on familiar forms. Beneath the waves, there are already tens of thousands of plant and animal species. The advance of life seems unstoppable. For life on land. 460 million years ago, and the plates have moved again. Below lies a new continent, Gondwana. It's a warm 30 degrees Celsius. Oxygen levels are close to a kind of gas called ozone. This gas forms a blanket around the planet. This ozone layer absorbs the lethal radiation. Over 120 million years, the ozone layer gets thicker and stops more and more radiation from reaching the Earth's surface. Life on land simply wouldn't exist. Now, shielded from radiation, life blossoms. Those small mossy lumps are the first land plants. And they're pumping out even more oxygen. Levels soar. $375 million years ago. Mountains act like a wall.
במידה והאנושות תיכחד מהעולם,